Tunisia, February 1943. The sand is still hot from yesterday's battle. German recovery crews drag a burned-out hulk through the desert, its paint blistered and cracked like old leather. One track blown clean off, bullet holes punched through the armor like someone had taken a can opener to it. This wasn't just any wreck. This was an American M4 Sherman tank, crew name painted in fading white letters on the side. War Daddy 2. And it was about to become the most important piece of intelligence that would fall into German hands that entire year. They loaded it onto a railway flat car, covered it with canvas, and sent it on a 1,000-mile journey to a place that didn't officially exist on any map. Kummersdorf proving ground, deep in the German countryside, where the Third Reich's best engineers tested captured equipment and developed their most advanced weapons. What those engineers found when they finally pried open that Sherman's hatches would shake their understanding of warfare to its very core. And here's the kicker. It had nothing to do with armor thickness, gun caliber, or engine horsepower. The German team at Kummersdorf had been testing captured Allied equipment for years by this point. They'd examined Russian T-34s, British Matildas, even early American tanks like the M3 They had protocols, measurement standards, firing tests, mobility trials. They knew what to look for. Superior German engineering had become almost a religion by 1943. The Panzer IV was being upgunned with long 75mm cannons. The Panther was in final development, incorporating lessons learned from fighting Soviet armor on the Eastern Front. The Tiger I had already earned its fearsome reputation, its 88mm gun able to punch through just about anything the Allies could field. German tank design philosophy focused on quality over quantity, on creating superior machines that could dominate any battlefield engagement. Each Panther was a masterpiece of engineering. Each Tiger represented hundreds of hours of skilled labor. German tanks weren't just vehicles. They were statements of technological superiority, rolling fortresses that embodied everything the Third Reich believed about itself. So when War Daddy 2 rolled through the gates of Kummersdorf on that spring morning in 1943, the German engineers already knew what they'd find. American tanks were crude, hastily built, mass-produced junk. Everyone knew that. The Americans couldn't match German precision manufacturing. They didn't have the metallurgical expertise. Their tanks would be simple, unsophisticated, probably unreliable. The inspection would confirm what they already believed, provide some technical specifications for intelligence reports, maybe reveal a weakness or two that could be exploited in North Africa. It was going to be routine. They brought in cutting torches to access sections the battle damage had sealed shut. They photographed every detail. They created technical drawings. They measured armor angles and thicknesses. They pulled the engine, examined the transmission, studied the suspension system. And slowly, as the days turned into weeks, something started to happen that made these veteran engineers deeply, profoundly uncomfortable. Their assumptions weren't just being challenged. They were being systematically demolished. The first shock came from the armor, not its thickness. The Germans had expected the Sherman to be lightly armored compared to their heavy tanks. No, what stunned them was how the armor was made. German tanks used face-hardened armor, a complex process that created a super hard outer layer while keeping the inner layer somewhat softer to prevent shattering. It was sophisticated, expensive, and required skilled metallurgists to get right. The Sherman's armor was just rolled homogeneous steel. Simple, crude even. But here's what the Kummersdorf engineers discovered. It worked almost as well, and it was infinitely easier to manufacture. Face-hardened armor might stop a shell slightly better, but if that shell managed to penetrate, the hardened face could fracture and send deadly spalling fragments ricocheting through the crew compartment. The Sherman's simpler armor might let a few more shells through, but it was less likely to kill its crew from its own fragmentation. More importantly, rolled homogeneous steel could be produced in any steel mill. You didn't need specialists. You didn't need exotic materials. You didn't need months of training. The Americans had looked at the problem of tank armor and asked a question that had never occurred to German engineers. What if good enough is actually better than perfect? But that was just the beginning. When they pulled the Sherman's engine, the real education started. German tanks used specialized engines, purpose-built for tanks, each one a marvel of engineering. The Maybach engines in Panthers and Tigers were powerful, sophisticated, efficient, and absolutely irreplaceable. If one broke down, you needed another Maybach tank engine. There was no substitute. The Americans had put a Continental R-975 radial aircraft engine in the Sherman. Some versions used multiple truck engines. The German engineers stared at this and initially laughed. Aircraft engines in tanks? Truck motors welded together? It was ridiculous, another sign of American industrial desperation. Then they started doing the math. The Continental R-975 wasn't just used in Sherman tanks. It powered American aircraft. It ran in dozens of different applications, which meant parts were everywhere. A Sherman with a blown engine didn't need a specialized replacement flown in from Detroit. It could be fixed with parts from a wrecked airplane, from a depot, from another Sherman. The Germans had built their tanks around the idea of engineering excellence. The Americans had built theirs around the idea of logistics. And at Kummersdorf, looking at this burned-out Sherman with its interchangeable, standardized, widely available components, the German engineers started to understand which philosophy would win a war. The transmission told the same story, but even more dramatically. German tank transmissions were precision instruments, each one specifically designed for that particular tank model. The Panther's transmission was notorious. It was incredibly complex, prone to failure, and took highly skilled technicians many hours to replace. When a Panther threw a transmission on the Eastern Front, that tank was often out of action for days, sometimes weeks. And God help you if you were in the field without access to a dedicated repair facility. The Sherman's transmission was almost insultingly simple by comparison. It was based on a design that had been refined over years of civilian truck manufacturing. It wasn't optimized for tanks specifically. It wasn't the most efficient design possible, but a moderately trained mechanic could pull it and replace it in a few hours. The parts were standardized. Multiple suppliers made compatible components. If one broke, you didn't need to wait for a specialized replacement from the factory. You grabbed another one from the supply chain and bolted it in. The German report from Kummersdorf contains a fascinating note, written in the dry technical language of military engineering, but you can almost feel the dawning horror behind the words. The American tank is designed for ease of field maintenance to a degree that compromises ultimate performance, but ensures high operational readiness rates. Let's talk about what that actually meant on the battlefield, because this is where the Sherman's secret started to become truly devastating. The Germans had been designing tanks under the assumption that combat was the hard part. Build a tank that could win its engagements, and you'd win the war. But the Americans understood something deeper. They understood that getting tanks to the battlefield, keeping them running, and replacing losses mattered just as much as, maybe more than, how well each individual tank performed in combat. A Tiger I was absolutely superior to a Sherman in almost every measurable way. Better gun, better armor, better optics. In a straight-up fight, the Tiger won almost every time. But here's what the Kummersdorf engineers discovered. A Tiger averaged maybe 300 kilometers between mechanical failures. A Sherman averaged over 5,000. Read that again. The Sherman could run nearly 20 times longer between breakdowns than Germany's most advanced heavy tank. And when it did break down, it could be fixed faster, with more readily available parts, by less specialized personnel. The Tiger might win the battle, but the Sherman would win the war. The tracks were another revelation. German tank tracks were engineering marvels, designed to distribute weight perfectly, to provide optimal traction, to last as long as possible. They were also incredibly complex to manufacture and difficult to replace in the field. A Tiger's tracks required specialized tools and trained personnel to properly install. The Sherman used tracks that were almost comically simple by comparison. Basically steel shoes bolted to steel links. They weren't as durable as German tracks. They didn't provide quite as good traction. But a crew could replace a damaged section with basic tools in under an hour, and the tracks themselves could be manufactured by any facility with basic metalworking capabilities. Once again, the Americans had asked that dangerous question. What if good enough, producible in massive quantities and easily maintainable beats perfect? The gun situation was perhaps the most nuanced discovery. The Sherman's 75mm gun was, by 1943 standards, adequate but not impressive. It could handle German Panzer IVs on reasonably even terms. It could threaten the sides and rear of heavier tanks. But it couldn't penetrate a Tiger or Panther frontally except at very close range. The Kummersdorf engineers fired the captured Sherman's gun, studied its performance, and concluded what everyone already knew. It was inferior to German tank guns. But then they examined something that made them pause. The gun's mount, the stabilization system, the ammunition storage. The Sherman had a gyrostabilizer that allowed it to fire with reasonable accuracy while moving. German tanks had to stop to shoot accurately. The Sherman's gun could be elevated and depressed through a wider range than most German designs, giving it better performance in uneven terrain. The ammunition was stored in wet racks, surrounded by a water-glycerin mixture that would help suppress fires if the tank was penetrated. German tanks stored ammunition dry, which meant a penetrating hit often led to catastrophic ammunition fires. The Sherman's gun might be less powerful, but the system as a whole was designed to keep crews alive and fighting. Again, that American design philosophy. Don't build the perfect tank, build the tank that maximizes your soldiers' survival and operational effectiveness. When the German engineers examined the Sherman's crew layout and internal ergonomics, they found more surprises. The interior was spacious compared to German designs. There was room to move, to work, to operate. German tank design tended toward cramped interiors, packing everything as tightly as possible to minimize the tank's profile. It made sense from an engineering standpoint: smaller target, more armor for the weight. But the Americans had prioritized crew efficiency. A Sherman crew could work for longer periods without fatigue. They could escape the tank more quickly if it was hit. They could perform basic maintenance from inside the vehicle. The difference wasn't huge for a single battle, but over campaigns lasting months, crew fatigue was a real factor. A Sherman crew might be more effective after their 10th consecutive day of combat than a German crew in a technically superior tank simply because they weren't as physically and mentally exhausted from operating their vehicle. The electrical system was another eye-opener. German tanks used complex electrical systems, carefully designed, highly capable, and absolutely miserable to troubleshoot in the field. The Sherman used what was essentially a heavy-duty truck electrical system. Simple, robust, easy to repair. It wasn't sophisticated, but it worked. The German engineers testing the electrical system at Kummersdorf noted that an American soldier with basic training could diagnose and repair most electrical faults with simple tools. A German tank's electrical problems often required specialized diagnostic equipment and factory-trained technicians. Once more, that same pattern. The Americans had sacrificed theoretical excellence for practical, field-maintainable functionality. Here's where it gets really interesting. The Kummersdorf evaluation dragged on through the spring of 1943, and as it did, the German engineers started comparing their findings to field reports coming in from North Africa. And the field reports confirmed everything they were discovering on the test ground. German units reported that American tanks seemed to be everywhere. They'd destroy 3 Shermans in a battle, and the next day there would be 5 more. Meanwhile, German tank strength was declining. Not primarily because of combat losses, though those were significant, but because tanks were breaking down and couldn't be repaired. A Panzer IV with a thrown track might be out of action for days because the replacement parts were back in Germany. A Tiger with transmission problems could immobilize itself just driving to the battlefield. Panthers were legendary for their mechanical unreliability. Entire units would start a battle at half strength not because of enemy action, but because half their tanks had broken down on the approach march. The Sherman, by contrast, seemed almost indestructible from a mechanical standpoint. Allied units reported operational readiness rates above 90%. Even after heavy fighting, tank units could maintain their strength because damaged vehicles were being repaired and returned to action faster than they were being destroyed. The secret wasn't that the Sherman was a better tank in the sense of superior performance. The secret was that the Sherman was a better weapon system in the sense of actually being available to fight. You can have the best tank in the world, but if it's in the repair depot when the battle happens, it might as well not exist. The Germans had been playing a completely different game than the Americans. They'd been trying to build the best chess pieces. The Americans had been trying to make sure they always had pieces on the board. The standardization was perhaps the most painful revelation for the German engineers. The Sherman wasn't just one tank. It was a family of tanks built around standardized components. There was the M4 with the welded hull and Continental engine. The M4A1 with the cast hull. The M4A2 with diesel engines for the Marines and Lend-Lease. The M4A3 with the Ford GAA engine. The M4A4 with the Chrysler Multibank engine. Multiple factories, multiple engine options, multiple hull configurations, but all using huge numbers of interchangeable parts. A driver trained on one Sherman variant could operate any other with minimal additional training. A mechanic who knew how to fix M4A1S could work on M4A3S. Parts from one version could often be used on another. The Germans had gone the opposite direction. The Panzer IV, Panther, and Tiger shared almost no common components. They required different training, different maintenance procedures, different parts inventories. A unit equipped with mixed tank types was a logistics nightmare. The Americans had created a system. The Germans had created individual machines. And then there was the production question. The Kummersdorf engineers weren't just evaluating the tank itself. They were trying to understand American industrial capacity. The Sherman they were examining had been built at the Lima Locomotive Works in Ohio. Lima usually built railroad locomotives. The fact that a locomotive factory could switch to tank production and turn out vehicles like this one told the Germans something terrifying. American industry was fungible in a way German industry wasn't. The specialized factories building Panthers and Tigers couldn't easily switch to other products. They were purpose-built for those specific designs, using specialized tooling, requiring specialized workers. But the American approach, standardized designs, interchangeable parts, simplified manufacturing processes, meant that tank production could be distributed across multiple facilities, could be ramped up or down as needed, could survive the loss of individual factories. You could bomb the Lima plant into rubble, and Fisher Body in Detroit would keep building Shermans. Germany couldn't do that. Their tank production was concentrated, specialized, and irreplaceable. The report that came out of Kummersdorf after the evaluation of War Daddy II was classified and distributed only to senior military leadership and key industrial planners. Parts of it have survived, and they make for fascinating reading. The technical language tries to stay objective, but you can read between the lines and see the growing alarm. The German engineers understood what they'd found. They'd discovered that American tank design represented a completely different philosophy of warfare. One that prioritized sustainability, maintainability, and industrial scalability over raw performance. And they understood, though they couldn't quite bring themselves to state it directly in an official report, that Germany had no answer to this approach. You can't outproduce an enemy who's designed their entire military-industrial system around mass production. You can't win a war of attrition when your opponent can replace losses faster than you can inflict them and maintain higher operational readiness rates while doing it. Some German officers pushed for changes based on the Kummersdorf findings. There were proposals to simplify German tank designs, to focus on standardization, to prioritize mechanical reliability over ultimate performance. These proposals went nowhere. German industry by 1943 was already committed to its existing designs. The factory tooling, the supply chains, the workforce training, all of it was built around the current generation of tanks. Switching to a simplified mass production approach would have required shutting down tank production for months while factories retooled, and Germany couldn't afford that. They were locked into their design philosophy by the very success of their early war tanks. The Panzer III and IV had worked so well in Poland and France that the idea of German engineering superiority had become unquestionable doctrine. To admit that maybe the American approach was better would have meant admitting that the entire German industrial military system had been designed around the wrong priorities. Meanwhile, Sherman production was ramping up to levels the Germans couldn't even comprehend. The United States built over 49,000 Shermans during World War II. 49,000, plus thousands more of other tank types. Germany built about 6,000 Panthers and fewer than 1,500 Tigers. Yes, the Panther and Tiger were individually superior vehicles in most combat scenarios. But you're comparing 6,000 Panthers against 49,000 Shermans. Even if one Panther could reliably defeat 3 Shermans in combat, and battlefield data suggests the ratio was nowhere near that favorable to the Germans, the Americans could afford those losses and still have overwhelming numerical superiority. And that's before you factor in that half the Panthers might be in the repair depot at any given time, while 90% of the Shermans were combat ready. The crews told the real story. American tank crews might have complained about the Sherman, and they did, especially when facing Tigers and Panthers, but they also recognized that their tank was reliable. It would start in the morning. It would get them to the battlefield. If it broke down, it would be fixed relatively quickly. If it was knocked out, they'd get another one. German tank crews, especially in the late war period, developed a bitter gallows humor about their vehicles. Panthers breaking down on the drive to battle became such a common occurrence that it was just accepted as normal. Tiger units learned to factor mechanical failures into their tactical planning. You had the best tank in the world, but you couldn't count on it to actually work when you needed it. The Sherman's secret wasn't hidden in its armor, or its gun, or its engine. The secret was in the philosophy behind its design, a philosophy that the German engineers at Kummersdorf discovered, but their military and political leadership couldn't or wouldn't act on. The Americans had understood that modern industrial warfare wasn't about building the perfect weapon. It was about building weapons that could be produced in massive quantities, maintained in the field with minimal specialized support, and kept in action at high operational readiness rates. They'd looked at the problem of tank design and asked questions that hadn't occurred to the Germans. How many tanks can we build? How quickly can we replace losses? How do we keep tanks running in the field with supply lines stretched across oceans? How do we minimize the training burden on crews and mechanics? The answers to those questions led to a tank that was, in many measurable ways, inferior to its German counterparts, but was superior in the only way that ultimately mattered. It showed up to the fight, it worked, and there were always more of them. There's a deeper lesson here about technology and warfare that the Kummersdorf evaluation revealed. Superior technology doesn't automatically win wars. Sustainable technology wins wars. The most advanced weapon in the world is worthless if you can't build enough of them, can't keep them running, can't train enough people to use them, and can't replace them when they're lost. The Germans fell into a trap that's ensnared military planners throughout history. They optimized for the wrong variables. They optimized for individual performance rather than system performance. They built tanks that could dominate individual engagements but couldn't sustain campaigns. They created weapons that were masterpieces of engineering but nightmares of logistics. The Sherman, with its truck engines and simple transmission and basic armor and adequate gun, represented a kind of genius that's less flashy but more profound than engineering excellence. It represented the genius of understanding what actually matters in industrial warfare. It wasn't about having the best tank. It was about having enough tanks in the right places in working condition with trained crews, supported by a logistics system that could keep them fighting. The Germans could have learned this lesson in 1943 when they examined War Daddy II at Kummersdorf. They understood the implications. The technical reports make that clear. But understanding and acting are different things, and by 1943, Germany's industrial and military systems were too committed to their existing path to change direction. The final irony is that some German units, late in the war, captured Shermans and pressed them into service. And they loved them. German crews operating captured Shermans praised their reliability, their ease of maintenance, their availability of spare parts from American supply dumps. There are accounts of German units preferring captured Shermans to their own Panthers for certain roles because they knew the Shermans would work. The ultimate endorsement of American design philosophy came from the enemy themselves, but by then it was far too late for Germany to do anything about it. So when those German engineers at Kummersdorf first opened the hatches on that burned-out Sherman in the spring of 1943, they expected to find confirmation of German superiority. Instead, they found something that challenged their fundamental assumptions about how to design weapons for industrial warfare. They found a tank that was good enough, rather than perfect. They found interchangeable parts instead of bespoke components. They found standardization instead of specialization. They found a weapon system designed not to be the best tank in the world, but to be a tank that would actually be available to fight, that could be produced in overwhelming numbers, maintained in the field, and kept in action regardless of supply chain disruptions. That was the real secret of the Sherman. Not superior armor or firepower or mobility. The secret was sustainability, maintainability, and industrial scalability. In a long war of industrial attrition, those boring, unsexy qualities mattered more than all the engineering excellence in the world. The Sherman wasn't perfect. American tankers paid in blood for its deficiencies, particularly in the face of German heavy armor. Crews knew they were outgunned and underarmored compared to Tigers and Panthers, and that knowledge had real psychological impact. But they also knew that when they lost a tank, there would be another one. When their tank broke down, it would be fixed. When they needed parts, they'd be available. They might not have the best tank, but they had a tank that worked, and in a war of attrition that lasted years, that might be the most important thing of all. The German engineers at Kummersdorf understood this, documented it, reported it up the chain of command, and watched as nothing changed, because changing would have required admitting that Germany's vaunted engineering superiority had led them down a dead-end path. Today, the Sherman is often remembered as the tank that won World War II through sheer numbers, overwhelming German armor through quantity rather than quality. There's truth to that, but it misses the deeper point. The Sherman won because it was designed from the ground up to be sustainable in a long war. It won because its designers understood that logistics beats performance, that availability beats capability, that good enough in massive quantities beats perfect in small numbers. The real secret the Germans found when they opened that Sherman at Kummersdorf wasn't a piece of technology. It was a philosophy, a way of thinking about weapons design and industrial warfare that Germany couldn't match, couldn't counter, and ultimately couldn't survive. The Sherman was designed to win not by being the best tank, but by making sure that American tank crews always had a tank to fight in, that when that tank was damaged it could be fixed, and that when it was destroyed there was another one waiting. That was the secret. That was what the Germans discovered in 1943. And that was what ultimately helped win the war. Video metadata main title: When German Engineers Opened a Sherman and Found the Real Secret. Alternative titles: What German engineers discovered inside a captured Sherman tank changed everything. The Sherman tank secret that terrified German engineers at Kummersdorf. Why German engineers were shocked when they tested this American tank inside Kummersdorf. What Germany really thought about the Sherman tank. The uncomfortable truth German engineers found in a Sherman tank. Detailed description. In February 1943, a burned-out American M4 Sherman tank named War Daddy II was captured in Tunisia and sent to Germany's secret Kummersdorf proving ground. What German engineers discovered when they examined this tank would shake their understanding of warfare to its core. But it had nothing to do with armor, guns, or speed. This is the untold story of how German engineers evaluated America's most famous tank and discovered a design philosophy that was completely different from their own. While German tanks like the Tiger and Panther were engineered for maximum performance, the Sherman was designed around a completely different priority: sustainability in industrial warfare. Magnifying glass tilted left. What this video covers: the capture and testing of Sherman War Daddy II at Kummersdorf in 1943. Why German engineers were shocked by the Sherman's simple design. How American standardization defeated German engineering excellence. The real reason operational readiness mattered more than raw performance. Why a Sherman averaged 5,000 kilometers between failures, while Tigers managed only 300 km. The design philosophy that let America build 49,000 Shermans versus 6,000 Panthers. Why some German units preferred captured Shermans to their own tanks. This isn't just another Sherman versus Tiger comparison video. This is about two fundamentally different approaches to warfare, and why boring qualities like reliability, maintainability, and standardization mattered more than engineering excellence in winning World War II. Based on historical German testing reports from Kummersdorf, field documentation from North Africa and Europe, and analysis of wartime production and operational readiness statistics. Stopwatch timestamps: midnight. The capture of War Daddy II 3:45, arrival at Germany's secret test ground 8:20, the first shock, armor philosophy 14:35, engine design that changed everything 22:10, the transmission that terrified German engineers 28:50, why Sherman tracks were too simple 35:40, the gun nobody expected to work so well 42:15, interior design and crew survival 47:30. The electrical system revelation 52 verse 45, field reports confirm the findings 58:20, standardization versus specialization 1 hour 4 minutes and 50 seconds, American industrial philosophy 1 hour 11 minutes and 30 seconds, Germany's inability to adapt 1 hour 17 minutes and 20 seconds, production numbers that told the real story 1 hour 22 minutes and 40 seconds. German crews using captured Shermans 1 hour 27 minutes and 15 seconds. The real secret of the Sherman tank. Book's historical context. This video is based on documented German evaluation reports from Kummersdorf proving ground, wartime logistics records, tank reliability statistics, and post-war analysis of World War II armored warfare. The Sherman tank's design philosophy represented a fundamental shift in how America approached industrial warfare. Direct hit: why this matters. The lessons discovered at Kummersdorf in 1943 remain relevant today. The tension between building the best weapon versus building sustainable, maintainable systems that can be produced at scale continues to shape military procurement decisions. Hashtag WWII, hashtag Sherman tank, hashtag military history, hashtag tank warfare, hashtag Kummersdorf, hashtag German engineering, hashtag American industry, hashtag World War II, hashtag history, hashtag war stories, hashtag tank design, hashtag military engineering. If you found this story fascinating, you'll also enjoy our other deep dives into the untold engineering and strategic stories of World War II. Subscribe for more content that goes beyond the surface of military history.